I'm just recording it. Share screen. Students, whenever disconnect, kindly send me a message. I hope you're able to see my PPT. Anyone can give me some indication?
Yes, sir.
Yes, sir, it's visible.
Yeah, thank you. Come on. Yeah, sorry, students. Is it visible now, the screen?
Yes, sir.
Yeah, somehow it's gave some trouble. So often the pure components or substances are classified into three things: solid, liquid, and gas. But in reality, this components doesn't exist in pure condition. Rather, it will exist either as solid-solid mixture, solid-liquid mixture, or solid gas mixture, or liquid-liquid mixture, liquid gas mixture, or gas-gas mixture, or it could be a solid, liquid, and gas mixtures. So never we will get 100% pure components, very rare. So we often we available to us the raw materials available to us or products coming out from reactor will be always mixtures. So we use various unit operations to separate them into individual components. So in the last class, we have started with liquid mixers. Liquid mixers are divided into two subsections, are classified into two. One is immiscible, example is oil in water. Another one is miscible. Two liquids completely mix each other and forms like a complete solution. In immiscible, we still distinguish two phases separately. We will have oil phase and we have water phase. In case of miscible, we cannot separate them into two individual phases. We will have a complete single phase. Example, ethanol water. Once you mix ethanol and water, visibly we cannot distinguish them, and it's completely mixed and will completely convert into a single phase liquid. So we have seen immiscible liquids. If two liquids are miscible, if the density difference is very high, simply by gravity settling we can separate them. Simply by gravity settling we can separate them. Often these gravity settling chambers are called as decanters. In a technical terminology, these gravity settling chambers are called decanters. If density difference is low, if density difference is low, where the separation with gravity is tough, we use centrifugal separators. In technical terms, the centrifugal separators are called centrifuges. Sometimes, sometimes these immiscible liquids, the immiscible liquids, for example, oil in water, can be formed as emulsions. Can be formed as emulsions. When these immiscible liquids forms in emulsions, by definition, emulsion is fine droplets of fine dispersion of minute droplets or fine droplets of one liquid is dispersed in another liquid. The another liquid is immiscible. So when you have emulsions, we will not be able to separate them just by either by centrifuge or by gravity settling directly, because there are two types of emulsions. One is surfactant stabilized emulsions. Another one is particle stabilized emulsions. Either in case of surfactant stabilized or particle stabilized emulsions, the surfactant molecule stays at the interface between oil and water, one phase to another phase, that is droplets to the continuous phase. In case of particle stabilized emulsion, the particles stays at the interface between oil and water. So first of all, we need to break that interface. We need to break that interface. So, so before, if you want to separate emulsions, that is immiscible liquids which is formed as an emulsions, we need to break these emulsions. We need to break that interface, interfacial tension or attractive force at the interface. So we add often anti-emulsion or foaming agents. Both are same. Anti-emulsion or foaming agents. So we will add this that will basically neutralizes the surface charge at the interface and to break the emulsion. Then you will have two different phases. Then we can use either by centrifuge or by the decanters. If you have the particles, we have to add salts that neutralizes the particles. Then it breaks the emulsion. Then we can separate them. So that's what we have seen in the last class. Now we have miscible liquids. Miscible liquid means both liquids mixed together forms as a continuous solution and into a single phase. So if you want to separate miscible liquids, right, we have various methods. We have various methods that can be used to separate the miscible liquids. One is distillation, another one is extraction, another one is adsorption. These three can be used. Another one is membrane separation. We have these four primary methods available to separate miscible liquids, right? Definitely, I think you're already learning this in mass transfer course. Here, as I said in the last class, we don't go in details of this unit operations. If we have a condition like this, let's say we have two liquids exist, now we need to separate them. Which method you need to use? If you can quickly tell that we can use this method, that's sufficient for this as part of this course. So, if the boiling point difference is high, the most preferred method to separate miscible liquids is distillation. Like example, we have ethanol and we have water, right? Well, ethanol boiling point is 78.5 and water boiling point is 20. The difference is more than 20. Water boiling point is 100 degrees centigrade. The difference is more than 20 degrees centigrade. So it will be easy to separate these two liquids with help of distillation. If you have only two components, we use binary distillation like single distillation column. If we have more than two components, let's say we have n components, we have to use n minus 1 number of distillation columns to separate them into individual components. So when we have more than one distillation column, we often, or more than two components present, we call that as multi-component distillation. If boiling point difference is low, then we cannot use distillation because of the either number of trays in distillation column required will be very high, or there's a chance of vegetable formation. So we will not be able to use distillation, or we can use it, but it won't be economical to use distillation. So, like example I have given, often extraction should be followed with the distillation. Nowadays, we have the extractive distillation coming, both can be done, extraction and distillation can be done at simultaneously, that is called extractive distillation. So, both methods can be used. For example, when you have a crude distillation, after the crude distillation, we have aromatics and non-aromatics comes together, like N-heptane and benzene. N-heptane and benzene. Although N-heptane and benzene forms a miscible, sorry, one second. So here aromatics and non-aromatics. One example is N-heptane and benzene. Suppose we have N-heptane and benzene liquid mixture, right? N-heptane and benzene forms a miscible liquids. It forms a solution. We will not be able to separate them, or if you use distillation, it would be not economical to separate them. So first they do extract one component with the help of a solvent, then they will do the distillation process to separate them. Another scenario, in case of miscible liquid mixtures, another unit operation we can use for a miscible liquid mixtures is adsorption with a suitable adsorbent. Adsorption with a suitable adsorbent. Here I'm giving an example here. Suppose we have water, some organic pollutants like phenols, biphenyls, or fertilizers, dissolved fertilizers present in water. We won't prefer to use adsorption here because in case of this pollutants present in the water, even though let's say if you take phenols in water, sometimes we have the boiling point difference very high, but still we won't prefer distillation because the quantity of these pollutants in the water is very, very low. The quantity of pollutants present in the water is very, very low. Often it will be in few grams per liter or few milligrams per liter. If you use distillation, it is not at all economical process. So at that time, rather than using distillation, even though the boiling point difference is high, certain cases, we don't prefer a distillation, rather we prefer adsorption because the concentration of these liquid components present in the liquid or water are very low condition. Like if suppose the dissolved fertilizers are present in water, often anyway we can't use distillation because of this melting point is very low. So conditions like based on the scenario to scenario, based on the conditions, we use either distillation or extractive distillation or adsorption followed by distillation or adsorption process, or we use membrane separation. It is case to case. It is case to case basis. we will get to know. We'll explain more individual details as course proceeds, and I'm sure you will also learn parallelly with mass transfer course when to use which process. But in a general guidelines, if boiling point difference is high, we prefer distillation. But at the same time, the ratios of both liquids should be it should be around 50% or 30 to 70%. It's not like something is 1%, the other one is 99%. We never use distillation for that. If boiling point difference is low, we have to go for extractive distillation, or we have to go for the adsorption followed by some other method to remove the solvents. Another thing is membrane separation. Another method which we can use the miscible liquid mixtures is membrane separation. membrane separation, to be able to do membrane separation, the molecule size difference should be significant. If you want to use membrane separation, the molecule size difference should be significant. Suppose if you use water, if you use other pollutant, the molecules of phenols and molecule size of phenols and molecules of water should be significantly different. Then only we can use the membrane separation. If molecule size is same or close to each other, and membrane separation is not a preferred method. Not a preferred method. So membrane separation is based on molecule size, distillation is based on the boiling point difference, and extraction is based on the solubility, and adsorption is based on the ability to adsorb onto this. There is a quantity called adsorption ability. So based on these parameters, we decide which method we use it. So as I said, as we go through industrial processes, when I explain case to case, I will tell you which method, why we're using this method, what are the criteria. That way you will get to know more and more details. So next case, I'm taking gas-gas mixtures. Suppose you have a gas, like we have air. Air contains nitrogen and oxygen, and it also contains CO2 and other other pollutants. So this is gas-gas mixture. If you wanted to separate, let's say we wanted to separate one gas component, or we wanted to separate like we wanted to separate them into individual components, what are the unit operations we use? Students are able to follow what I'm trying to convey? Is it making some sense or just going away? So this is the problem with online classes, because
Yes, sir.
I'm teaching without seeing you. So if you can give me input, let's see if you're not able to understand, if you're not able to follow, or if not something making sense, kindly rise up and ask me so that I can change the way I want to explain. So when we have a gas-gas mixtures, the most popular method is gas absorption. Gas absorption is the popular method of all. This is the popular method to separate gas-gas mixtures, right? How do we do absorption? I'm sure you are aware of it. So we have a two mixtures. We have two mixtures, A and C. A and C. So one is solute, another one is non-solute, and we have the solvent. So B is solvent. If you wanted to separate, the A is gas and C is gas, and both are present in as a mixture. And we wanted to separate them into individual components. We wanted to separate them into individual components. So these gas mixes are being separated with help of a liquid solvent. If you are able to separate two gases, if you're able to separate two gases in the form of gas mixture with help of a liquid solvent, that is called absorption. That is called gas absorption. If you have a liquid mixtures and you are separating them with help of a liquid solvent, that is called, any idea? If we have a two liquids, if we have a liquid mixture and we are separating them into individual components with help of a liquid solvent, what is that unit operation is called? Anyone can guess? Can anyone tell me? Sorry, I could not hear. Can you say again?
Extraction.
Extraction. True. So just I explained before, that is extraction. We have a two liquid mixture. If we two liquids in present as a mixture, and we separate them as individual components with help of liquid solvent, that is called extraction. We have a two gas components present as a mixture, and we separate them into individual components with help of a liquid solvent, that is called absorption. Here, the liquid solvent is selected such that the liquid solvent is selected such that one of the two gases has more solubility than others. One of the two gases has more solubility than others. Let's say we have A and C, and A is soluble in this liquid solvent much more higher than C. A is soluble in this liquid solvent much more than C. Then only we can use gas absorption. For example, uh, for example, we have CO2 present in the air. We have CO2 present in the air, and we wanted to remove this CO2. We wanted to remove this CO2. So if I bring NaOH, if I add NaOH into this container, like I have NaOH, and on top of that we have CO2 and air. If I mix it, if I mix it, if I rigorously mix it, can anyone guess what will happen? Can anyone guess what will happen? I have liquid NaOH at the bottom, I have CO2 and air at the top, then I rigorously mixed. Can anyone guess what will happen after mixing? Again, I have two phases. Sorry?
Bicarbonate will form.
Bicarbonate will form. That is CO2 diffuses and transfers to NaOH, and we have air in the top. Air doesn't air solubility in NaOH is very low compared to the solubility of CO2 in NaOH. So that way, after mixing, what will happen is that depends on the concentration of NaOH, all the CO2, just for the ideal case, all the CO2 will transfer to NaOH and only air remains. This way, I'm able to separate CO2 from the air. I'm able to separate CO2 from the air with help of liquid NaOH that we call a solvent here. So that type of separation, that type of unit operation is called gas absorption. Similarly, H2S also we can separate with the help of the liquid solvents. Students, just give me 1 second. Yeah. So that is one, gas absorption. Now, at certain conditions, we have we have two gases. Again, we have two gases like CO2 and air, but where CO2 is very, very small quantity. Let's say the CO2 is very, very small quantity. Like let's say industrial emissions will have CO2 more quantity, but in an atmospheric air, CO2 quantity is very less. If CO2 quantity is very low, that is in the gas mixers, the quantity of one component is very, very low compared to the other quantity. At that time, we prefer to go for scrubbing. At the time, we prefer to go for scrubbing. At the time, we prefer to go for scrubbing. So the scrubbing, even in the scrubbing, the phenomena of mass transfer is still absorption. Even in the scrubbing, the phenomena of mass transfer is still absorption, but only the process conditions are slightly different. Only the process conditions are slightly different. So what it is? So Thank you, Varun, for reminding me or for informing me. Uh, may I know when it got disconnected? Just before this slide or previous slide also?
You were telling about scrubbing.
Scrubbing.
Okay. Yeah. So, sorry guys, I'm facing a lot of trouble today. I don't know why. Yeah. So when you have two gas mixes, when one quantity is very low compared to other quantity, we use scrubbing. For example, the CO2 concentration in the atmospheric air is very low. At the time, instead of using absorption, we prefer to use scrubbing. In the scrubbing, we bubble this gas in the pool of liquid. In the scrubbing process, we bubble the gas in the pool of liquid. When you bubble the gas, what will happen is air and CO2 gas bubbles will move, will pass along the liquid solution. At the interface, the CO2 has more solubility towards solvent, hence the CO2 will diffuse into the liquid, and that way we're able to separate CO2 from the air. So scrubbing is more preferred when we have the one quantity is very low compared to the other quantity. For example, CO2, let's say CO2 air. If the CO2 concentration in ppms, obviously we don't use absorption. Rather, we use the scrubbing method. That is the more efficient and more economical compared to the absorption. Now, to separate gas-gas mixers, another unit operation which we can use is adsorption. In the adsorption, the gas-gas mixers are separated with help of a solid adsorbent. The gas-gas mixers are separated with help of a solid adsorbent that is called adsorption. In this case, same, if you take same scenario, the same example, that is removal of CO2 from air, removal of CO2 from air. We can use a liquid solvent like NaOH. We can also use solid adsorbent called solid adsorbent like amine functionalized silica or amine functionalized any substrate can be used for the separation of or removal of CO2 from the air. That is one example, but there are many examples we can give for the removal of gas-gas mixtures from the separation of gas-gas mixtures with help of a solid adsorbent. Another unit operation which we can use is gas separation membranes. Again, if you want to use membranes, the molecule size should be significantly different. Suppose we have nitrogen, we have hydrogen, we have oxygen. Each molecule, it has its own size. So if the molecule size is close, that is the average molecular weight is close, we will not be able to separate them with or the efficiency of the gas separation membranes are lower. If the molecular weight of the gases are closer, the separation with the membranes are difficult. Now another case we take solid-solid mixers. Solid-solid mixers. There are two types of solid-solid mixes possible. One is homogeneous, another one is heterogeneous. Homogeneous, heterogeneous doesn't mean we have the two different of course, solid-solid mixes means two different components. But if uniformly dispersed, that's called homogeneous. If non-uniformly dispersed is called heterogeneous. Right? For example, if you take alloys, nickel alloys, or like if you take many alloys, they uniformly distributed along the matrix. Another example is carbonate rocks that is uniformly distributed along the matrix. So if when you have two materials, if you have two solid liquid mixers, one of the important unit operation which we can use is leaching. One of the important unit operation which we can use is leaching. In the leaching, in the leaching, solid liquid mixers are separated with help of a liquid solvent. In the leaching, solid mixers are separated with help of a liquid solvent that is called leaching. Like we have two minerals, two metals, or two solids are uniformly distributed. But out of these two, one is more soluble in the liquid solvent. Other one is less soluble in liquid solvent. Then we go for the leaching. In case of heterogeneous, example is iron ore. The iron ore contain many of the impurities. Many of the impurities. Now those impurities are not uniformly distributed. Not uniformly distributed. Also, we will be able to separate them into individual grains. We will be able to separate them into individual grains. In case of homogeneous, everything is like a single metal, single material. Everything is like a single material. Like nowadays, we all see gold ornaments, right? The gold ornaments are mixed with copper. When gold alone cannot be made as ornament, gold is mixed with copper, then made as ornament. But you can see that both copper and gold is together stays as a single solid. That's what's called homogeneous solid. But in case of in case of heterogeneous, both are we can separate them grain boundaries. We can separate them individual components. Like another example I give, you'll understand better for heterogeneous is um, sand and stones. Like both are mixed, but physically we can also separate them. Both are uniformly mixed, but physically we can separate them. It comes under heterogeneous classification. So if if we have if the melting point difference between two solid materials are significantly different, if the melting point of the two solid materials are significantly different, then we can separate them simply by heating. We can separate them simply by heating. If two are different materials, let's say if you have two of different materials and different size, we can simply separate them by with help of sieving. I hope you are understanding whatever I'm trying to explain. We have solid mixer. One is homogeneous, and the one is heterogeneous. In homogeneous solid mixer, both solids are present as a single solid. Example is gold and copper present in the gold ornament. Like our alloys, nickel alloys, or even the steel, whatever we are seeing the steel, it's an alloy. Both solid materials present as a single solid material. If you want to separate such type of homogeneous solid mixers, we can use leaching method. In leaching method, we will use a liquid solvent in which one of the two solids are dissolves more than other material. In case of heterogeneous, if melting point difference is high, based on simple heating method, we can separate them into two single components. Another one is we can do the sieving. We can do the sieving method. For example, if you take the if we ever seen the steel plant or steel industry by any chance, if you have at least look into it, the iron ore contains iron plus many other impurities. Now, the iron melts at 1100 degrees centigrade. Iron melts at 1100 degrees centigrade. Whereas impurities doesn't melt at 1100 degrees centigrade. They melt at much more higher temperature. So how do we separate iron from iron ore or those impurities? If we heat the whole iron ore at 1100 degrees centigrade, only iron ore melts and converts to liquid form, whereas impurities still in the remain solid form. So that way, after melting at 1100 degrees centigrade temperature, we have a liquid iron and we have the non-meltable impurities. That way, we'll able to separate them into solid phase, liquid phase. Though that liquid iron is removed and further processed to get whatever materials we wanted. So that is way we can separate them solid mixer. So far we have seen liquid gas and solid mixers. Suppose we have the gas solid. Suppose we have the gas solid. Can anyone give me example of gas solid? In which condition we say gas solid is exist? Any scenario? Can anyone explain?
Smoke.
Smoke, yes. One good example is smoke. That is solid particles are dispersed in a gas medium. Like in the smoke, we have gases and we have the fine particles of dust and carbon will present. Right? Very good. How do we separate them? How do we separate the solid particles from the gas?
We can use chimney.
Chimney? Chimney is only to emit the gases, no?
Filters.
Chimney filters, yes, we can use filters. Very good. Any other? Depends on the particle size. Can we suggest something else? One is filter, definitely filter. But if it is hot, let's say the smoke is hot, so we will not be able to use normal filters because most of the filters are made of polymers. So it might be like good idea to use filters if it is hot. So any other methods we choose or we can use to separate gas solid mixes, which we have seen in mechanical operations course. Are you getting any idea apart from filters?
Electrostatic precipitator.
Yes, electrostatic precipitator we can use. That is one. Any other one?
Based on size difference, maybe we can use any other separators which we learned.
Like name any one example.
So for example, cyclone separator.
Yes, cyclone separator. True. So we can use back filters or filters, or we can use cyclone separators, or we can use electrostatic precipitator. It depends on the charging ability and particle size and what are the characteristics we have seen already. Another example, one is solid particles are trapped in gas. Another example also possible that gas is trapped in a solid, like we have a gas hydrates. You might have heard the gas is trapped in a rock. Gas is trapped in a rock, like natural gas is trapped in a rock or and in that case, what we do? Suppose a gas is trapped in a solid. How do we separate them? With the help of desorption. With help of desorption. Or desorption is opposite of adsorption. Like we have a gas is trapped in a solid. When we purge another gas through that one, because of the concentration gradient, whatever gas trapped in the solid material tend to diffuse outside. They tend to diffuse outside. So that way, desorption method can be used to separate if the gas is trapped in a solid particle. If solid particles are dispersed in gas, just now you all told what are the methods we can use. If gas is trapped in solid particles, we can use desorption to separate them.
So is sponge ball an example of gas trapped in solid?
Which one? Can you repeat? I do not hear.
Sponge ball.
Sponge ball. Oh, means the air is in the sponge that way?
Yes, sir.
Yes, that is true. Suppose, yeah, the same example. Suppose we have the, let's say, some argon gas is trapped in the sponge ball instead of air. If you wanted to separate that argon from that sponge, whatever foam, we can, if you purge some air through that one very fast, the argon will be diffused into air because of the concentration gradient. Because argon concentration in the air is zero, right? Let's suppose this is the sponge ball. Sorry. Okay. Sorry, again disconnected my screen. Yeah, sorry, I'm not able to write. So yeah, we have a sponge in which we have some gas trapped. Now, if you want to remove that gas trapped in the sponge, how do we do? By purging other gas through that one. And the argon, let's say argon in the sponge, argon concentration in the sponge is very high. Whereas if you purge a gas over the sponge, where the argon concentration is almost zero, because of the concentration different, the argon diffuses from the sponge to the air. Okay. Did I answer your question?
Yes, sir.
Yeah. So next one is gas liquid. The next one is gas liquid. So another again, the scenario is we can take gas liquid is the simplest scenario we can think of is fine droplets of water in the air, right? We see mist formation in the air. Or in winter season, we can very well relate to this one. So how do we separate that water droplets in air? We can pass through a porous super adsorbent like a cotton, a sponge or something, then obviously the fine droplets will be absorbed onto that super adsorbent. Or we can bubble, we can bubble this gas liquid mixture through a pool of liquid. Then the liquid will be dispersed in the liquid loves liquid, so liquid will be transferred towards liquid and gas will be remain and gas will come outside. Another we can use is compression. If we use high pressure, and we know water vapor present in the water droplets can get compressed and condensed in the liquid, but gas will not be condensed. Opposite of that is gas molecules or gas bubbles are trapped in liquid stream. Gas trapped in liquid stream. Again, we can use bubbling and we can also use solid adsorbent. Solid adsorbent. Now, so that's what we have seen, gas liquid and gas solid. Now we have a gas, solid, and liquid. All three are present. Gas, solid, and liquid, all three are present. So we will not be able to deal them all the three at a time. So we have out of three, we have to separate the one first, then we have to separate other two using the existing techniques. So often if we have a gas, solid, and liquid, we'll tend to separate solids because that is easier to separate by using any cyclone separator or filters. We can separate them solid particles. Then we can purify. Then it comes to a case of gas liquid or liquid gas, and accordingly we can use different unit operations to separate them. So we have seen all possible combinations like solid, solid, liquid, liquid, gas, gas. or gas liquid or liquid gas, all the six combinations, how to treat. Of course, I have only given very few what you already know it. Later on, some of the cases where different unit operators will come, at that time we will explain those details. Any questions, students? Do you understood whatever I'm trying to convey? If you got any questions, kindly ask me. Probably no questions. So that is one. Another one is transportation of solids, like we have seen in the mechanical operation. So I don't think I need to spend any time here. We use conveyors. One is belt conveyor, bucket elevators. This is what we have seen, and screw conveyors. This also we have seen in the mechanical operations course. Then we also use pneumatic conveyors. We also seen this pneumatic conveyor um, in the mechanical operations, so I don't have to spend much time here. Transportation of liquids and gases. These are also another types of unit operations. So we use pumps, centrifugal pump. This is centrifugal pump. Then we have the positive displacement pumps, reciprocating pumps are the positive displacement pumps. I hope you have learned this in the fluid mechanics course. So these are for the transportation of liquids. We use centrifugal pumps and positive displacement pumps and rotary pump. This is the example for rotary pump or typical cross section of a rotary pump. Another is diaphragm pump. If we have a if the solid particles are present in the liquids, if the solid particles are present in liquids, if we need to transport slurries, solid particles present in liquid means slurries. If we need to transport slurries, we use diaphragm pumps. We use diaphragm pumps. Example, suppose if you go to any pharmaceutical industry where they have to transport the concentrated slurries from one position to another position, that's where we have to use diaphragm pumps. We can't use centrifugal pumps or reciprocating pumps. So if you visit any pharmaceutical industry, often you will see diaphragm pumps. If you visit any oil refinery, you will see centrifugal pumps. Even often you will see centrifugal pumps or reciprocating pumps. So fans, blowers, and compressors are used for the transportation of gases. Fans, blowers, and compressors are used for the transportation of gases. Fans and blowers acts based on the centrifugal action, compressors based on the reciprocating action. Fans and blowers are similar in terms of functioning. Only difference is fans can only give very little amount of pressure than the blower, whereas compressors can give much more higher pressure. So this is a students. Do you know how the centrifugal pump works? Did I explain or did you see in any other course?
So actually, we have not seen the working of different type of pumps.
Oh, we have not seen. So maybe, yeah, I think I will spend few minutes as it's already 10:56. I will explain in next class on different pumps, how they work and what are the differences. Maybe it will be useful if at all you visit an industry. I think I will continue from here. This is further vacuum jet ejectors. Uh, I don't know. Maybe last year I taught. Right? So we'll continue vacuum generation and pumps in the next class. So if you have any questions, you can ask me. Otherwise, we will stop here. Maybe you can join the next class if we have. I hope you're able to follow with this distraction of getting disconnected in between. If it is making sense, there will be more good. If you could not understand, or if the way I'm explaining is not making good sense, please do let me know. Okay, we can always find a better way to explain. Aman, you are trying to say something. You're muted actually. Aman, are you trying to say something? Actually,